Testing, testing. Here we are back again at the Rhino introductions. I'll shut down my Grasshopper currently, and I think this chapter is probably the most important chapter, at least what I see in this tutorial guide. And the reason being, um, if you take a look at it, it basically covers precision modeling, which can really set you on a wonderful tangent that you realize, surfaces are surfaces, solids are solids, but they're from surfaces that are directed from curves that are, interpolated through points, and points have attributes. So you're going to need to know X, Y, Z to get things going, and then it can get much more complex as you code through that. But if you take a look through here, not only is the chapter fairly large and has a lot of modeling exercises, especially in the 6th version, but you can actually get in here and make some really nice precision geometries, which are the basis of architectures, rings, product design, and they extend that to some very interesting transformations as you get into these shapes of these arrows and then into these other gadgets and gears and widgets and all this wonderful stuff. So we basically want to get ourselves organized that we can build within, and actually the elevator mode is actually fantastic to learn on. So you want to get into that for sure. The chair example is fantastic at that, drawing from a couple of pictures and surfaces that you have, and importing pictures to get a variety of chairs. And I think they end with even more precision. Build a little kid's toy, a couple more gadgets, a couple more engineered parts. They throw on some fillet tools, I think, a little later, and you end with a toy in this pair. Oh, no, they go farther into the helix, into the coil, into the screwdriver, and you end with the screwdriver. So really nice stuff. So let's go back to precision modeling. And we will jump into it. Now, Grasshopper is going to be awesome to pair this against it. So what they suggest is not even bothering with any of this stuff. Go in and give yourself a new file. Make yourself in millimeters. And that's interesting that comes up. Hit OK. And you should have a new file. And they suggest right here that you want to call it something. So they initially say, give that name, save as a file within Grasshopper. We have lines, we have selected objects. They suggest for 6.1, call it boxes. And now we have a little file in Rhino, and we'll do the same in Grasshopper as we go. And initially they're like, okay, you want to build a box. So the best way to build a box would be to construct it. And they're going to construct it from a rectangle, and a precise rectangle at that. So into curves, is that where rectangle is? Right here. And suggestion, I don't even think they go there, which is even better. I think they take it one step back into line and say, let's create a polyline. So let's do that. And a polyline, we're going to build the coordinates. And we're going to take a look at our top view, how to do that. And read your command line. This isn't so great in Mac, but it's certainly great in Windows. Let's start it at 0, 0, and we could say 0. Well, I'm going to say O. I want to say 0, 0, and you could say 0. It's kind of irrelevant because we're looking at it in 2D. And hit Enter, and you've got the start of that line. And there it is. And this is how you end up getting into precision. Now, this is very important to know these attributes for these points, 0, 0, 0, because then you can play with that Grasshopper and have a wonderful time with it. The next point of the polyline, they suggest we can leave off the Z coordinate. We can take the X coordinate as 5, 0, and there you go. And the next one we can have 5, 5, and the next one we can have 0 in the X and 5 in the Y. And you'll see up here it has this wonderful little thing called close. And there we go. We've got a nice little rectangle. If we go back to all of our sides, all of our viewports, and we go to standard, and you'll get in the habit of right-clicking here on Zoom Extends All. You can go into viewport, into view, and then make the viewport layout to 4. You can go into what is that, standard toolbar, and jumping in here and try and find the icon for Zoom Extends All. I just like the right click because it puts everything in there really sweet and nice. And that's a nice way to begin with that rectangle. Now, how could you start to play off of, how could you write that a different way? And I'm going to produce that again, and we're going to produce it just a little higher. So we are going to do a curve, We're going to do a curve polyline. And we're going to start, just leave this hovering wherever, but let's have the start that it's actually 0, 0. And let's start with it at 10. And let's type that in. And there it is. I put it, it looks like it's right above on the top viewport, but if we look over here, you'll see it's actually way up here, centered above that original point right here. If I had ortho, you'd see that that line is directly above that line set above 10. And maybe 10's a little too far, but let's just leave it. We can leave, that's going to fall around my cursor wherever on that target. But let's type in the next line. But let's do it as a reference. So R, we're going to refer to that line, and we're going to move it 5 in the X and 0 in the Y. And now we don't need that Z because we're working on that plane. We're going to hit Enter, and we're going to do a reference up 5, and we actually can write it almost the exact same way. And I think, oh, bad mistake. I actually just wanted my next reference to be reference. We want to go 0 in the X and up in the Y. And you can see where it's being pointed. And then this one as a reference, we're going to want to go -5 in the X and comma 0. And hit that, and then we can go to our close function, and there we go. So we produced the other one from reference points as opposed to world coordinate points. So that's a nice thing to know about. And they go through that, and then they go so far as to say, hey, you can use some really cool things like angles within that, and you can reference a degree to where you want to go and a distance to that as well. I'll leave that up to you to kind of plug through that. I don't think it's necessary for me to get into those angles, even though it is helpful. Well, maybe I should do one example. So let's see what polar coordinates. 4, we want to go distance 4. Let's start again. This time we will go into curve and produce curve, a line, a polyline, polyline. And we're going to start with 0, 0, and comma 5, put it in the middle. And then from here, I actually want to move that, and this can be kind of exciting. Well, not super exciting, but exciting enough. I can take a line as to what I have. So let's just take this exactly, and let's draw 4 units, or let's draw 5 units at angle, and you can use the angle symbol, which is the less than symbol, at 90 degrees. That's exactly what it did. It drew it out 90 degrees from that point, which is pretty interesting, but it put it back down on the plane below. And what I probably should have done is go back and say, start of the polyline. Let's do a reference. Well, let's do it again. 0, 0, and 5. And then let's have it reference 5 in distance to the angle. This is kind of nice. We could do 45-degree angle. We could do 90-degree angle. We could do -90-degree angle. And you can see how this starts to rotate and move. We could do -180 degrees. We could do 270 degrees, which is going to be 90 degrees. But -2, well, whoa, we got 18,000. Let's go -270 degrees. And you'll see that's the same as going 90 degrees. So you're working in a degrees, 360 degrees, and go 360 degrees and loop around again. So a nice little thing is, let's just go -90. And let's just take it to 45 degrees. See what happened. Try and envision what that's doing. And let's take it to -270, which is up here. And what I'm going to do is keep it at 0 degrees, and you'll see that it goes straight out. And that was -0, and 0 is the same as -0, which doesn't make sense because -0 and 0 are pretty much the same thing. So we could draw it out that way by using angles. And so let's do the next line, and then let's do the next line as a relative 5 in length, and let's do the angle again to 90, because we knew that drew it out this way. So this is just a fun way to be precise and think differently than maybe how you have. And the reason I say go through this this lecture, again, is because relearning Rhino after knowing a bit about Grasshopper and programming in these other programs, Revit, or whatever you want to play with, you will unlearn bad habits and you will start learning some very good habits. So let's post that one in, and let's take another one by going relative item, 5 in distance, comma, and get in the habit of, let's say, negative 90 degrees is not where I want to go. And that's very interesting that it jumped like crazy into a distance like that. Relative 5, comma, I think I hit decimal. Instead of a comma, negative 90. Nope. Negative 270. This is interesting that what did I do so wrong? Let me go back and let's have my relative 5, comma, 90. Well, that's strange. 90 millimeters. Why is that extending so far out? And I was having no problem. What have I done? What did I do? Next polyline from there. Relative. Oh, it's because I was using angles, and then all of a sudden I went back to commas. So you get distracted. It's not hard, and I don't mind showing how foolish I am. Let's type this one into 0. Let's do relative 5 distance to 90 degrees. And once again, I did it again. Angle 90 degrees. Then let's do relative 5 to angle negative 90s, not where I want to go. Let's do 270, not where I want to go. Let's do 180, and that's exactly where I go, negative 180, which there we go, and I can hit my close. So you end up thinking geometrically, and you've made all of those polylines differently, but in the end, you're left with the same kind of thing. And that's really where you have to start thinking on this. And I rambled on a little bit for 12 minutes. Distance constraint is another wonderful thing that you can type into here with your polylines, that you can actually set a limit on where you want to go if you wanted to draw something out. So if I started with a polyline, I'll just do this, polyline, and I started at 0, and you can just type 0 for 0. It'll assume that x, y, and you go over here to here, but you limit the distance to 4. You can see that I can bring it over here, but it won't come farther than that. It's limiting that. So if I went to, let's say, 10 and doubled it, I could do a pretty interesting pattern on this bottom one and say, let's take it out 10, and let's use the degrees, 45 degrees. And then let's use relative 10. And you'll understand how this becomes interesting when you start programming and dealing with fractals and playing off these numbers as iterations. But let's just take a distance 10 and go negative 45 degrees. Actually, I have to do my angle again. I seem to be having a bad habit with that. Negative 45, which would put it in this direction. And I'm going to go counterclockwise with this, which is not great practice for meshes. You should go counterclockwise. You shouldn't go clockwise. So I'm going to do a relative item 10 again, and make that in an angle of, let's say, negative 45 degrees. See which way it goes. I don't want to go there. I want to go maybe positive 45 degrees to make a zigzag. Or I could go negative 135, which is where I end up wanting to go. And I can pull a close on that one. And I've made another rectangle that's been playful in that way. And of course, they use a great example of now, can you script and write relative items and make a beautiful arrow? And they suggest starting the model at negative 11 and 0. So that was a little exercise, not really worth keeping. Best to just go in here and say new. You don't need to save that. Make small miniature ones, hit save. And then this one, I'll just continue this series. Why not? Save as, boxes. And even though I didn't do anything with it, I'm going to call it arrow. We may end up using this again. And I'm going to go fully out on perspective just for fun, so you can kind of get a sense of what's happening, and you can be careful that you're not going in the Z direction. But they said create a polyline from what you learned, and we'll try and do it in Grasshopper afterwards and make it kind of interesting. We could reference the curve and then make it very We could play around with the sections of it, but I think we can kind of program an arrow afterwards. What I like to do is design very simple geometric flags on a two-dimensional grid and design my own logos and flags in Grasshopper to kind of represent different things. So let's just go into here and have Polyline, and let's do exactly what they said. They said start at -11 and 0. Comma 0, and there's your starting point of your arrow. And they will literally walk you through relative items and say, okay, your next point is going to be relative to that -2 and 2, and you're going to draw back on that arrow, and I'm going to zoom in because this is going to get real small. And you can kind of guess where this arrow's going, and then it says the next point, you literally can just type in 8 because it understands 800. But you do with that, the next point, 8 with ortho on is interesting. It can't go any other way, so you can put on ortho, so you could just have a length of 8. So let's just type in 8 and see what it looks like. And so that's one way to do that. And I like having ortho on because it's going to push in that direction, but you can see this wonderful thing. It'll snap to 90 degrees. You can change ortho in your settings to be any degree increment you want, but right now it's set to 90-degree increments. And then a relative item, we're going to type in the next one, relative item 1 and 1. Let's go back because I had 8. The next polyline, I believe, was 8 as a limit, and I want to enter that. And now I'll have to take my ortho off. Well, let's put it on and do our little click for enter. Then let's take our ortho off and see where we want to go. And we are going to do a relative item. And let's just make sure we're still flat. And they're going to suggest doing a relative item of 1. And I think it's a typo because it's going to go in the wrong direction. So you're definitely going to want to go 1, -1, and get your little arrow curve on that. And then I think they go back to saying relative to that, you could go a relative 11 distance and just click it. But it doesn't have ortho on, so you want to go back in and make that relative 11 item and hit go. And there you go. That will click out. Interesting. Oh, relative 11. Relative 11. And they're just showing different ways of doing this, and they're messing with my mind at 0. And there you go. Enter that. And there you have that next point. And ortho can go off. So they're being very playful. At this point, I think they're just going to do-si-do up 1 with ortho on and make sure you're pointing in this direction and just move it up relative to 1. And we should have a, well, why didn't that go relative 1? Let's go relative, actually, let's just type in 0 and relative 1. And there you go, you got the 1. So there's many ways to try this. And I think going through the demo, it's trying to mess with you, so have a little fun with this and build your little arrow. And then what they're going to do is just end, they're going to pull down, and I'm going to end normally just pulling down and having grid snap on and saying, listen, I'm just going to snap to here and make an arrow. So in doing so, that was a roundabout way of being playful, but I like the way they've set it up. They're messing with you as you go. Relative items, coordinates, maybe angles, whatever you want to do. And they do some quick copies, and you could copy this and flip it. You could hit copy, paste, and then grab one of those and flip it over like this. Hold down your shift to make ortho. I mean, you could really kind of have fun with that, and then you're stuck. Okay, well, I got to move that over so it snaps and make my arrow that way. That's a roundabout way to do it, but they show you a little trick. You can jump on here and use your transform. One of the first transforms that's interesting is mirror. All you need is a plane, so you go from here to here. And actually, as long as you're in any direction ortho, it doesn't matter the length of that vector or that line. It actually is mirroring it against it. And when you're done both sides, you basically have an arrow that you can make solid and play around with that. Now, another thing you could do is you could go in here, and they show a quick example of making a surface by a revolve, and you'll need to grab that line and then make it revolve around here, and you'll see all these defaults. They're set to start angle 0. You can click on it, and then you can choose how far you want that to go over. And I'll just do a quick render so you kind of actually not render until it's close shaded. You can see how I'm drawing around that, but it defaults to full circle. So when you click that, you've got a nice little rounded form, and I believe it's still, no, it's capped in the end because we were right back to the point. So they show you how to make some pretty fun things like this. Just like when I go back to here, you could group this and join it with this little tool. And then there's a bunch of gumball shortcuts, but mainly you might want to make that solid by planar curve extrusion straight and draw it up. And I don't want to have on both sides. I just want to draw it up and choose how high I want it to be. And there you go. You make an arrow a different way. So you have a lot of fun with that. And then they actually get so far into, let's grab this object, go into transform, and have fun with bend, and start the spline here and take it down to here and then bend that. And you can have a lot of fun with what Rhino does well now. And this is not getting into subdivisions and anything like that. It's just getting into some pretty fun little toys. So we'll go back to this one right here. Oh, I thought I had it. I guess I erased it. Let's go back to here and let's just do a quick revolve. Surface revolve. We want to pin that to here. We'll do a full revolve, and then we'll grab our object. We'll go into a transform and have fun with the bend. And we can bend it from here to here. It really doesn't matter. It's like you see, you can really get kind of funky and make that do some odd things that maybe you didn't intend. And that's kind of just a fun tool to keep grabbing. Grab your object, do a quick bend of the spine from here to here, and twist it up like that. So you really start to have fun, and you can start to program all of this. So now I'll just do it one more time and select the object to bend, grab this point, hit enter. Object to bend, grab from here and go to here and start to have fun with a different angle, like maybe here, and pull it up like that. So now you're starting to do, well, as a sculptor, you'll realize that anything kind of phallic is always enjoyable. And dangerous, so arrows that bend are usually going to be fun little items that people are excited about looking at and playing with. So I think that's just a fun little exercise in Rhino, and that runs through, and I think they continue. They give it, they use twists on it. They get on to a bunch of fun, playful things to do. But that said, which is something I like to say often, we've played off of this. We have a nice little rendering of this little form with our original curve. We have, I'm going to do zoom extends all. I'm going to go into here and grab my X-ray view. Actually, maybe not X-ray, technical view. I'm going to grab my little pen view. I'm going to grab my artistic view. And with that, you've got something, like, for experimenting and playfulness that's kind of fun. What I'm going to do is slam it over here. Go back into this full view with that object. I'm going to take it back into shaded, and we're going to play around a little bit with our awesome grasshopper. And I hope you're enjoying this. This is really how I teach. Usually I stretch things out, I ramble on, I make a lot of mistakes in front of people, but let's do the same type of thing. Let's take a curve, and yes, we could have taken that curve and made it interpolated through the points. So we could bring it in here and say set one curve. And there we go. We have a ghosted form in Grasshopper that's not dependent on there. But when I click that, I see a bunch of points. And that excites me. So I'm going to take this little object and hide that away visibility. I'm going to go into this object, and I'm going to say select points. Select points. And I like to chase back things from surfaces to curves to points to attributes. And if you remember, we started this whole project with coordinates and relative point coordinates. So if I grab all those and I decide, no, I'm going to make this object instead by selecting multiple points, and I'm going to select that one and that one. I'm making sure I do it in order. And of course, I could have selected the ones that were there. You'll see already with this object selected as points, everything erased and taken hidden. This curve I can put on right click and hit off. I have these points, and now, just quickly from these points, in good old Grasshopper, interpolated, makes a very weird arrow. It's going to make a totally different thing if I go in and make it into Polyline. And you might realize that curve is something you just had. And then there's a bunch of other things juicy in here, like vertices as NURBS curves. And I kind of like the NURBS curve one. So what I do is I make decisions, and this is no different than when I'm working in Wickerson Studio plugins or GH nodes or C# nodes. I give myself an array, because to me these are just C# nodes that are scripted, except when I double click them I can't see what's in them. when I use my nodes, I can go in and see what's actually scripted in the node. And that's where we'll end up getting with this series, hopefully. This one, when you double click, you get nothing. When you right click, you get a help menu. That's not giving you the details of that, but it's giving you a little bit of information. And that's where I think, it's kind of like people keeping you ignorant because they don't want to scare you. They don't want to use your brain too much. So let's just take these three and turn them off. And let's go with this little curve. And let's say, well, what did we do? Well, I'm pretty sure without hard coding, I can make a line. I can go in here and have a line. Let's see, where am I going to go? Primitive. A line start, stop, direction. And you can export things like extracting. And that point is actually, that would be a point somewhere. So that would be here. And I am going to go so far as to say, let's go into vectors and let's construct a point. And my constructing point is basically there. It started there. And I want the direction to be a vector in the x direction. So I'm going to do that. And the length really doesn't matter as long as it has some type of value. So I always extract and say, okay, there's a number there. And if you're ever wondering what's extracted, you can use your panel tools to see what's there. You got the number 1, you got the x vector, and you get the point that's been constructed. Now what's nice about that is you can go in here, type in a number slider 2, and you start to play with that point. So not only is that point there, you're starting to move that sucker around and have some fun with it. And that's when things start to get parametric. And I think parametricism carries right through machine learning and AI because you set parameters for what you want in generative work. And I'm starting to have a really interesting discussion with others about that as to whether or not you have control, lose control, or you gain control. And you lose your ego or start dealing with autonomous things. So that's a long way around to make a little tiny line. But I need that little tiny line because I want this curve to transform Euclidean, revolve three-way, and I need my geometry to revolve an angle around an axis, and I don't want to default to the angle 0.5 pi. For those that deal in degrees, well, you're going to realize I like pi. And with that, I am going to set up a range. I'm going to set up a pi factor, and I'm going to, actually, I'm just going to type in 0, ... which means 2, 2.0. It's going to default to 0, but I'm going to bring it up to 2. And I want that to revolve 2 pi. And as you can see, that's exactly what's happening. So I've revolved that around, and I've ended up with another geometry. If I do that, what's nice is I can have that curve. I'm going to be a little playful here, because this is where Grasshopper starts to get really exciting to me when I get into the maths and start playing like this. If I have it go through a range, and we've done that before, but I remember grade 10 math is about ranges and domains. I'm going to have it take 10 steps through that, and there it is. But it's only going in an angle of 1 pi total. I want that domain, which you can go into maths and set your domain. I want that domain to go from 0 to 0 to 2.0 pi. So now I can take it and have control over how many curves do I want going all the way around that. And I believe if you take a look over here, I have, it's a little tricky to see in this direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 around that I believe I can take those lines and throw that through a surface edit of what's called a loft, and we should have some success. And there we go. We have a very interesting little tiny, let it load up there for a second. There we go. It takes a little second to load when you start popping it into different things, and I have a totally different rendered object that if I took it to a bake and make it exist in real and link it all together, I've got a pretty cool little structure here rendered. And I can leave the Grasshopper window by clicking out like that. And I have a very interesting arrow that not only is there as a object that's been baked into one iteration, I can go in here and start to play off of many iterations for that, which is what it's all about.